Hi, my name is Anand Prabhupatar. Today we are going to present experiential learning of the robot design. The topic is flow test on cement mortar under the guidelines of Dr. Bhathi sir. These are the contents we are going to cover in this presentation. This is the introduction. Overview of the study is this study evaluates the workability of the cement mortar by varying the water and cement ratio, determining the desired flow percentage. It should be 100 plus or minus 5 percentage. This is the theory of the experiment. The objective of the study is the flow test will be used to determine the variation in the workability of cement mortar with the different water and cement ratios. The water and cement ratio, which is the cement mortar, to identify the optimal water and cement ratio required to achieve 100 plus or minus 5 percentage. The study the importance of the study is to achieve the right workability, ensures the proper compactation, which increases the strength of the structures and reduces the voids. These are the advantages of this study. Optimizing the water and cement ratio, which helps the avoid the excess of water usage. This is the objective and apparatus which is used in our experiment. These are the apparatus. This is the flow table. This is the cement mortar. This is the procedure. The first one is wipe the flow table clean and dry. This is the table. We have to clean and dry initially. Place the flow mold at the center. This is the mold. Place at the center. Then place the first layer of the mortar. The Fill the first layer of the mortar and temp 20 times of using of temper, and fill second layer and lift this mold. Immediately drop 25 times by rotating of this rotor. It will oscillates up and down 25 times. We have to do about 15 seconds, and measure this diameter, final diameter. To calculate the flow percentage, this is the formula: average diameter of the motor minus base diameter. This is the average diameter, and this is the base diameter. Initially we have taken base diameter divided by base diameter into 100. This is it, which gives the flow percentage of the mortar. This is the tabular column. Here we have considered the two factors, water and cement. uh, Here I considered both are in 5 levels, water in 5 level and cement in 5 levels. These are the expected flow percentage. In this tabular column, we can see up to here we can accept these all values, the ratio of the cement and water. But here we can see up to here the value is uh, plus or minus 105 percentage, but here it is above the 115 percentage. These all values are rejected. This is the experiment design and methodology. These are the factors what I have considered: cement and water, and design summary, and two factors, file each at 5 levels and 25 runs. Methodologies to conduct this experiment: to vary the cement and water, and record the diameters, and calculate the flow percentage. This is the procedure we are going to see now.
Open Mini tab, click on Start, DOE factorial create factorial design. And in create factorial design, click on general full factorial design. And in our experiment we have two factors, so I'm keeping it as two only. If you have three factor means change it to three. And display available designs, click OK. And in designs rename the factors name by our experimental factors name. That is, our first factor is water in liters, and second factor is cement in kg. We are taking these two factors in 5 level, so I'm typing it as 5 and keep the number of replicants one only. Click OK and click on factors. You can see this Minitab created 5 into 5 level of factors for both the factors. Click OK and go to options. Check the randomizer and store design in worksheet and click on results. Make sure that summary table is checked and finally click OK. And Minitab has created the multi-level factorial design with two factors and the with total experiment of 25 and number of levels is 5 into 5. And here you can see um, it is also created a two columns for the two factors and also standard order run order, that is all automatically calculated. Here our values are different from the values are here. So what we have to do is we have to replace these two columns, that is water and cement, with our values. So go to Excel and copy these two columns. To see and paste it here. Now the values has been replaced and now click on uh, C7 column and here we are going to add response. So go to Excel, copy the response name. Our response is expected flow percentage. Copy it and paste it here and also copy the values also and paste them here. Now we have to add this response to our experiment. So click on expected flow percentage, go to stat, DOE, factorial, analyze factorial design. Here, click on the expected flow percentage and click select. Once the response has been selected, go to terms and click this AB multiplier and add it to the available terms and click OK. Covariance no change and options also no change. Stepwise also no change. And in graphs, in this experiment, I am going to plot all the four histogram, normal plot, and residuals versus fades and residual versus order in a single plot. So I'm clicking it as 4 in 1 and also residual versus variable plot. Click OK and then go to results. Make sure that all these boxes are checked and go to storage and check the fits and residuals. Click OK. OK. Unitab has created fits and residuals, the difference values, and now it is also created ANOVA table here, analysis of variance. You can also see the p values which are ranging from 0.0002 to 0.002, and here we also see the r value and also coefficients. And this is the regression equation for the response, and this is the Pareto chart, and these four are the residual plots. That is, first one is normal probability, second one is residual versus fitted, and histogram and versus order, residual versus order plot. And finally, we have to plot main effect plots and interaction plots. For that, again go to stat, DOE, factorial. Here click on factorial plots and change the terms to display to all terms, and the factors will be same only, no change. In options, no change. In graphs, make sure that the main effect plots and interaction plots are checked. Click OK. OK. And this is the main effect plot for factors and responses, and this is the interaction plots. Here you can observe that in main effect plot both the factors are differentiated, they are not in the same graph, but in the interaction both factors are combined with the response. This is the difference.
In the Minitab software, these are the results whatever we got from the Minitab software. By applying this, these are the standard orders, these are the run order, point type and blocks. These are the all input. This is the conclusion. The flow test on the cement motor identifies the optimum water cement ratios to achieve the 100 plus or minus 5 percentage. Optimizing the ratios ensures the proper compaction and reduces the void. The experiment provides the efficient guidelines for the achieving optimal motor workability. Thank you.